Okay, long day, I confused myself. What we can do with this is we can draw at B an imaginary north-south line, and we know this angle. That's that 53 degrees, 19 minutes, 14 seconds east. Let's go ahead and convert that to decimal. 19 times 60 plus 14. Divide by 3,600. Add the 63. So we know this is 63.321 degrees. Well, we've got a 90-degree angle here because we have a north-south line, we have an east-west line. 90 minus, boom, we get an angle here, this little tiny acute angle here of 26.679 degrees. Based on triangle having 180 degrees, 180 minus 26.679, 150, oh, subtract that 90 also. 63.321. And that makes sense too because of our parallel line situation. That allows us to find the coordinates for B. Because we have the coordinates for C now, and we can use this information, these angles, what we have already, to find these line lengths here. Let's go ahead and do it. We have 374 feet as given information. We can divide that by sine 90. It's going to give us 374 still. We can multiply by sine 26.679. We get the opposite side length from that angle, 167.923 feet. We can go ahead and do the same. 374 divided by sine 90, we get 374 again. Multiply that by sine 63.321. We get 334.182 feet. Given this information here, we're going to the north still. So we take 191.953 being the north position for C. We'll add this 167.923 to get a location of B at 359.876, and then we can go ahead and take this east 346.660 as being the easterly location of C. Well, we're moving to the west. We're going to subtract this 334.182. We get 12.478. and it still remains positive. It is still east. So now we have that location and we have the location of A. So that is going to tell us this line, because we now have the location of 2 points. So we can draw, you guessed it, an imaginary triangle. Another one. Okay, so we have an imaginary triangle here where the hypotenuse is the line that we're trying to solve. So let's go ahead and figure out the side lengths. Pretty easy. So we know that B is at 359.876 feet north. A is at 20 north. Well, all we have to do is take that 359.876, subtract 20, and that gives us a length on this side of this triangle of 339.876. Let's solve our east-west. Okay, A is at 65, B is only at 12.478, so let's take that 65, subtract that 12.478, and we get 52.522. Now, it's a simple Pythagorean theorem. 339.876 squared plus 52.522 squared. We take the square root of that solution there, and we have 343.910 feet. Okay, so that is the length of that line. So we know we're starting to get answers here. So we now know that between A and B is a line that is 343.910 feet in length. Let's find the bearing of that line. Well, we have plenty here to be able to do law of sines. So what I want to do, how should I do this? Because what I want to do is, I know that this angle here is actually the one that I need. But going back to this whole concept, if I solve this one, it's going to be the same. So this angle and this angle, because we've got these parallel lines and this is going through them, we can do that. So let's go ahead and we'll take sine of 90, divide it by its opposite, which is the hypotenuse here, divide it by 343.910, multiply by 52.522, because we want the opposite angle from that side. We're going to take the inverse sine of that number. We end up with this angle here being 8.785 degrees. Well, we see that that is northwest, so it's west of north. So we know that it is north 8 degrees. We'll convert this back over to minutes and seconds. So let's take that 0.785 and multiply by 60. I get 47.1. So that tells us we have 47 minutes. I take that 0.1 that's remaining, multiply it by 60 again to break it into seconds, and I get 6 seconds west. Now, let's say I want the azimuth also. Azimuth and bearing are pretty simple. I'm going to do it real quick, but in this instance, it's just going to be 360 minus that 8.785 is 351.215 degrees azimuth. So the line between A and B has bearing north 8 degrees, 47 minutes, 6 seconds west, azimuth 351.215 degrees, and has a length of 343.910 feet. So if that's all you needed help with, you can go ahead and turn off the video now. I'm going to go briefly into azimuth and bearing just to make sure that that is all clear. So this is really simple. Really simple. So azimuth is out of 360 degrees. So imagine you're facing north and it's going to be however many degrees you rotate around the whole circle. So if I have this line here, that would be, okay, so you're 0, 360 on the north, east is 90 degrees, straight south, 180 degrees, west is 270 degrees. So this line here, let's just say it is 210 degree azimuth. For finding bearing on this, really the easiest way, take that 210, subtract the 180. That means that this is 30 degrees. Well, it's south, it's west, it's south, 30 degrees west. If it is up here, let's say that it is, let's do a bearing on this one. Let's say it's north, and let's say that's 40 degrees west. Okay, well, we know that that 40 degrees represents this slice of the pie here. Well, that's not what azimuth is. Azimuth is all of this around here. So we take 360, we subtract that 40, and that means we get 320 degree azimuth for that. In your northeast quadrant, it's really easy because they're the same. You haven't crossed that 9 degree yet. Important thing to understand on bearing is that your bearing is always going to be expressed as a north, then some number of degrees east or west, or south some number of degrees east or west. It's never going to start with east. It's never going to start with west. That makes sense if you think of it from a magnetic compass perspective, which I can grab one. Okay, so a magnetic compass, everyone has GPS now, but a magnetic compass has this magnetized metal bar that is spinning around on this little spindle here. Sort of floating, you could say, I guess. Well, that bar points north-south. So from that perspective, it completely makes sense in the days before GPS that, okay, you're going to look either north or south, and then it's going to be some angle from that, rather than spinning around in a circle. Your instrument tells you north and south. You know, now we have GPS and the world's different, but so if you think about bearing from that perspective, though, of you're given information, the thing you have that can measure something just tells you north and south, well, then it makes sense. What's also kind of convenient about bearing as opposed to azimuth is, okay, we're at north 40 degrees west. Well, what if we turn around? What if we turn around? Well, now it's this line that we made up here. I don't know what this is even from, but that's very convenient that that's there. So now this line is going to be south, south 40 degrees east. Why did I even write that? Oh, I must have been writing it for this one. But this line is south 40 degrees east, so your number stays the same. It's just switch around the directions. So it makes sense from a more, I guess you call it primitive or more analog time period, where now with GPS it's not quite the same, but from a magnetic compass analog type perspective, bearing makes a lot of sense. And so converting between them is just thinking about what that bearing represents, because it's always going to be coming off of the north-south line. So it's always going to be filling in these pieces of the pie. It's never filling in this out here. And so then, well, here, we'll just add the bearing to 0 and you get the azimuth. The azimuth and the bearing are the same. You just take away the northeast portion for this quadrant. Down here, okay, well, you know south is 180, so subtract your bearing, and then you get this whole portion. Over here, your bearing, okay, you know 180, we'll add this bearing to 180, and that gives you all of that. Well, and over here, well, you're wanting all of this around to that line. Well, take your 360, subtract this portion, and you get that. Kind of looks all clumsy drawn out, but it's a fairly simple concept. To me, it's easier to just understand it than it is to memorize it. But everyone's different, so you can do it how you want. But I think that pretty well covers it. I hope it was helpful. If there's any questions, I think everyone knows how to contact me. So catch y'all later. Good luck on the test.